Hi, Assalamualaikum. Today, I want to explain the data arrangement. The data is randomly from Appendix 1. We have chosen 50 sample which is n equal to 50. The table 1 shows distribution frequency. First step, we must find the number of k. How to find the class k is 2 power k must bigger than 50. So 2 power 6 is bigger than 50, which is 64. So number class k is 6. Second step is class interval that we can find by maximum minus minimum entry divided the number of class. So 161 minus 30 divided by 6 equal to 21.83, round up 22. So the class size is 22. Table 2 is relative frequency. The frequency divided to sample size of n. Table 3 is cumulative frequency is class of the sum of the frequency for the class and all previous class. The cumulative frequency of the last class is equal to sample n.
Next, my part is graphical method. I do this part and I choose 2-part graph. The first graph is about the histogram and the second graph is about ogive. Histogram is about graph that represents the frequency distribution of the data set. Okay, you can look this picture. This is the table histogram. Have the 5 classes, which is lower class boundary, upper class boundary, midpoint and frequency. Okay, you can look the picture of the graph histogram. Line on the side I use frequency data and line the below I use the data midpoint. So this is the graph of histogram. Okay, the next graph is the graph ogive. So ogive is the line graph display the cumulative frequency of each class and its uppercase boundaries. Okay, you can look at the table. There are 4 classes, which is upper class boundary, frequency and cumulative frequency. Okay, there have 6 classes and the total of the frequency is 50. Look at the picture. So this is the graph ogive. Line on the sides I use the data frequency and line the below I use the data upper class boundaries.
Okay, next we move to median. For LM is LM equal 95.5, C equal 117.5 minus 95.5 equal 22. FM minus 1 equal 22. FM equal 16. And divided 2 equal 50 divided 2 equal 25. Therefore, about 50% labor force in Malaysia less than 1 to 7.13 and the others 50% spend more than 1 to 7.13. Okay, next we move to mode. For LM is LM equal 95.5, C equal 22, changes 1 equal 16 minus 7 equal 9, changes 2 equal 16 minus 5 equal 11. Therefore, the highest labor force in Malaysia during their most recent season is 105.5. Okay, next we move to the measure of variation. The answer is therefore the sample variance is 1427.13 and the sample standard deviation is 37.78. Okay, next we move to the shapes of data distribution. Mean 94.19, median 127.13, mode 105.4. The mean is smaller than the median is larger than the mode.
Next, for Pearson product movement correlation coefficient, we take the growth rate of total cases as an X, then geometric mean of interpersonal distance as a Y. After that, we find XY, x power 2 and power of 2. So that we can calculate by the formula given. are equal 449.46 minus 4.8052688.42 divided 3555.82 power of 2 210,837.47 minus 2688.47 power of 2, so get R equal negative 12468.64 divided 1930.62 and 151,440.51. So the answer we get is R equal negative 0.729. For that, there is very strong negative correlation at negative 0.729 between growth rate of total cases and geometric mean of interpersonal distance.
Now we move to regression equation. Based on the data collected, the answer for beta 1 is 1.46 and the answer for the beta 0 is 76.61. So, the objective is to establish a relationship between independent variable and dependent variable. Our linear equation is to have beta 0, which we are going to be calling the intercept, and the beta 1, which term that we multiplied to x, and we are going to be calling coefficient. I will interpret the B0, which is when growth rate of total case x is 0, the geometric means of interpersonal distance, which is y, will equal to $76.61. For beta 1, for every 1 unit increase from growth rate of total class x, the geometric means of interpersonal distance y will increase by $1.46 unit. That's all from our group. Thank you.